Techno-commercial appraisals are essential for understanding the feasibility of photovoltaic (PV) projects, ultimately guiding investment decisions. Also referred to as techno-economic viability (TEV) studies, these appraisals are predominantly utilized by lenders for making informed lending decisions, including debt restructuring. Equity investors also rely on these assessments to evaluate potential investments. The appraisal process encompasses several critical areas: technical feasibility, operations and maintenance, O&M plan, financial viability, permits and clearances, management capabilities, risk assessment and mitigation, investor-specific requirements. Appraisers gather necessary information from project developers and conduct an independent review of the submitted proposals. This review includes evaluating the reasonableness of the information and its sources. The completeness of the data varies with the project stage. At inception, information is often tentative, but it becomes more comprehensive as the project advances. Technical feasibility evaluates the suitability of the proposed site and the project's technical configuration. Key considerations include site location and condition, site ownership. The developer must own or have rights to the land for the project's duration. Site conditions. The site must support solar modules and equipment with adequate evidence for civil work design. Topography and connectivity. The layout should adapt to the site's topography, and there must be sufficient transport connectivity for materials and personnel. Power evacuation. Assess the capacity of the power evacuation substation and compliance with local grid codes. Local climate. Analyze temperature, wind, rainfall, and humidity for accurate energy generation estimates. Security and preparation. Implement security measures and prepare the site by removing obstacles and ensuring safety. Solar resource assessment. Estimate energy generation based on local conditions, utilizing P90 data for accuracy. Plant specifications and layout. Detail the technology and specifications of major components, such as PV modules and inverters. Plant performance simulation. Simulate energy generation using software to estimate monthly and annual outputs. Construction schedule. Outline critical paths, milestones, and necessary permits. Information review methodology. Review data sources for reasonableness and authenticity. Conduct documentary reviews for ownership, construction schedules, and power evacuation. An effective O&M plan identifies key operating parameters, maintenance procedures, and schedules necessary for optimal plant performance and financial viability. The appraisal of the O&M plan includes resource planning, ensure availability of manpower and water, system monitoring, implement methods for continuous monitoring, preventative maintenance, establish a schedule to prevent breakdowns, breakdown maintenance strategy, develop a strategy for addressing unexpected failures, minimizing downtime, create strategies to reduce operational interruptions. Insurance plan. Ensure adequate coverage for potential risks. Security measures. Implement robust security protocols. Spare parts strategy. Maintain an inventory of critical spare parts. Skill development. Train personnel to enhance operational efficiency. Information review methodology. Conduct documentary reviews and compare with similar plans. Financial viability assessments are tailored to the specific requirements of different investors. Equity investors typically focus on metrics such as equity internal rate of return, EIRR, and payback periods, while lenders prioritize the debt service coverage ratio, DSCR. Government agencies often utilize the levelized cost of energy, LCOE, for their evaluations. Key inputs for assessing financial viability include project cost. The total project cost should be estimated based on firm and valid commercial quotations from vendors and then compared with similar projects. This encompasses costs of plant and equipment, manpower expenses, soft costs, interest incurred during construction, costs associated with licenses, permits, and approvals, insurance premiums during transport and construction, revenue estimates. Revenue is projected based on energy generation and applicable tariffs. For projects lacking power purchase agreements, PPAs, such as mini-grids and solar pumps, revenue estimation must consider load surveys, energy consumption patterns, competition from the grid, and overall revenue realization. Depreciation. Account for asset depreciation over time. Replacement costs include future costs for replacing equipment. O&M costs factor in ongoing operational and maintenance expenses. Financial parameters assess various financial metrics, including debt-equity ratio, required return on equity, interest rates, payment schedules, and repayment terms for loans. Working capital requirements, tax obligations, available incentives such as capital subsidies, interest rate subventions, tax holidays, and accelerated depreciation. Information review methodology. Conduct documentary reviews of quotations and purchase orders for project costs. Analyze revenue estimates, including reviewing PPAs and load surveys. Validate calculations against local accounting and taxation laws. Review other costs, including O&M expenses, and compare with similar projects. Interview investors and project developers to gather insights on financial parameters. Review the financial model and perform sensitivity analyses to assess potential returns. The appraisal must identify all necessary permits and clearances required from relevant departments, along with tentative timelines for obtaining them. This ensures compliance and facilitates smooth project execution. Information review methodology. Refer to local policies, regulations, and laws to identify requirements and processes. Gather documentary evidence of applications and approvals. The appraisal should evaluate the capabilities of the developers to execute and operate the plant effectively, ensuring projected returns are achieved. This assessment includes legal status. Verify the legal standing of the developer. Organizational performance. Assess both technical and financial performance. Management track record. Review the history and success of the management team. Project team qualifications. Evaluate the qualifications and experience of the project team. Information review methodology. Conduct documentary reviews and interviews with the project developer. Identifying and mitigating associated risks is crucial for project success. The appraisal must evaluate potential risks and their impacts, including project execution risks, delays in permits, cost overruns, and quality issues during construction. Design and implementation risks, challenges related to plant design and execution planning. Operational risks, issues concerning technology performance and energy generation forecasting. Regulatory constraints, compliance with local regulations and requirements. Financial risks, risks related to revenue realization and competition, particularly for projects without long-term PPAs. Offtake risks, challenges in energy offtake, including grid stability and availability of evacuation routes. Information review methodology. Conduct documentary reviews to assess risks. Review warranties and guarantees for critical equipment, particularly solar PV modules and inverters. Techno-commercial appraisals must also address specific investor requirements, such as environmental and social impact assessments. These assessments enhance the project's overall value and ensure compliance with sustainability goals. In summary, techno-commercial appraisals are comprehensive evaluations that provide a roadmap for project success. By thoroughly addressing technical, financial, and operational aspects, these appraisals ensure that PV projects are sustainable, profitable, and impactful. The integration of investor-specific requirements further enhances the project's viability, paving the way for a greener future. Thanks for going through and reading. Don't forget to like, share, and subscribe for more solar insights from I-SED Academy. Please go to I-SED Academy platform for detailed learning about solar technologies.